Hello everyone. Today we are going to solve another problem on polynomials. Find the zeros of the polynomial x cubed minus 5x squared minus 16x plus 80. Now, if you look at this particular expression, it has x cubed, so it is not a quadratic equation. Had it been a quadratic equation, things would have been simpler. But now, this being x to the power 3, how can we try solving it? First thing we need to see is, can we see if we can come up with some kind of a relation between any two terms with another two terms, right? That's how we try to see. So let's see the very first two terms, x cube minus 5x squared. So it is 1 is to 5, the ratio. And if you look at the next two terms, again, here it is 16x plus 80. So again, if we look at the 16 table, 16 5s are 80. So here also it is 1 is to 5. Here also it is 1 is to 5. So looks like we can use this logic to see if we can break it down further and probably we might reach somewhere. So let us try having the first two terms in one bracket and the next two terms in the other bracket. So how do we solve it? X cube, let me write this again. I already messed it up by putting a lot of brackets. So x cube minus 5x square minus 16x plus 80. Now what do I do here? If we look at the first two terms, x cube and 5x square, x square is common. So let me take x square outside. So here we have x minus 5. Now with this we have already addressed up to here, right? Now let's look at the next one. So if you look at 16x and 80, we have 16 common here, right? So if I take minus 16 outside, and then what do we have? X, and it's again x minus 5. 16 5s are 80. Right? So now if you see, this looks like more of a quadratic form, isn't it? We can again now put this as x squared minus 16 because x minus 5 is common on the left as well as on the right expression. So x squared minus 16 into x minus 5. And now when we look at x squared minus 16, this again sounds very familiar for us, isn't it? 16 is 4 square. So x square minus 16 is x square minus 4 square. A square minus b square. So again it becomes a plus b into a minus b. So we can further break it up into x plus 4 into x minus 4. So x plus 4 into x minus 4. And then we have the third one as x minus 5 as is. So we have x equal to, if you look at the zeros, it will be minus 4 plus 4 and 5. So when we looked at this question first, it might have looked a little daunting because we have been asked to find the zeros of a polynomial with degree 3. But since that is given to us, if we try to break it further, we could probably get some ideas. Like we just did we just tried to see if we can get some kind of a ratios going here. So we could get the 1 is to 5 ratio from the first two expressions, which is similar in the third and fourth elements in this particular expression. And that's how we broke it down, and we were able to somehow bring it to a quadratic form which we are comfortable with to get the zeros of the equation. So that's how we solve this problem. And if at all in future in any of the exams, if you're given something similar, it may not be a 3-degree a polynomial with 3 degrees, it could be polynomial with 4 degrees as well, but probably we can apply this similar logic to see if we can come up with some kind of a relation between the first 2 or 3 terms with the next 2 or 3 terms, etc. All right, I hope you found this tutorial useful. Let's move on to the next problem solving exercise. Thank you very much.